Hello everyone. In this video, we will be discussing a numerical based on a compound gear train. In video 2, we had discussion on how to write the speed ratio and the train ratio equation for a compound gear train. Have a look on that particular video so that it will be easy for us to solve this problem. We'll have a look on the given question. The gearing of a machine tool is shown in sketch. The motor shaft is connected to gear A and rotates at 975 rpm. The gear wheels B, C, D and E are fixed to the parallel shafts rotating together. The final gear F is fixed on the output shaft. What is the speed of the gear F? The number of teeth on the each gear are as given below. We can able to see this. We have two compound gears, that is BC and DE. Both these gears are mounted on the common shafts, where A is the driver and they have mentioned the speed of the driver, that is 975 rpm. The number of teeth of all the gears is given in the table, that is A is 20, B is 50, C is 25, D is 75, E is 26 and F is 65. So in this problem they asked us to find out what is the speed of the gear F. So first we should be knowing how to write the speed ratio for a compound gear train. We know we have to consider the first gear and the last gear. So and according to the directions we can conclude and we can write it. So what is the formula? So before moving to the equation other things, we know that gear 1, if gear wheels, that is gear A, if it is rotating in the clockwise direction, that is the driver is rotating in the clockwise direction, means the final gear in between, let it be two compound gears or three compound gear, whatever it may be, the final gear should rotate in the direction opposite to the driver. If the driver is rotating the clockwise direction, means then the follower should rotate in anti-clockwise directions. So I'll be considering the formula as NA by NF, because this is the first gear, this is the last gear. So in case of formula, we'll be writing N1 1 2 3 4 5 6. So N1 by N6 will be considering. Since the gear names, instead of the numbers, here I'll be going with the alphabet. So NA by NF, which is equal to, what is the formula? We know that we need to consider the even numbers and the odd numbers. So in the numerator we need to consider the even numbers. So even numbers are, if NA is even number and speed, means we need to consider the teeth in the odd categories. So TA, TB, TC, TD, TE, TF. So 1 2 3 4 5 6. So all the even number of teeth you write it in the numerator and all the odd teeth you write in the denominator. Since the teeth total, the number of teeth for the respective gears is given in the question, I will be substituting, that is 50 into 75 into 65 divided by 20 into 25 into 26, which is equal to 18.75 I will be getting. So NA by NF, in the given question NA value is 975. So 975 divided by NF is equal to 18.75. So from this I can find out what is NF. So from the simplification I am getting it as 975 divided by 18.75, which is equal to 52 rpm. So when you are solving, if you are not comfortable with this ABCD means, you can follow this method only. So wherever the gears of given link, you can replace it with 1 2 3 4 5 6 7 8 like that, so that it will be easy for you to identify which is the even and which is the odd numbers. So here for this case I have written all the gears as numbers, so that for when I am writing the gear train equation, it is very easy to remember. So obviously the speed will be the driver divided by the follower, and the right hand side will be always on the numerator it is even number of teeth, and denominator odd teeth numbers I will be writing. So we will be getting the answer. In some cases, any one will be given. I mean, all the inputs will be given except one output. So that easily by using this case we can able to find out. And in the same even the same problem, they may ask us to find out even the train value. So train value will be the reciprocal of this one. So even we can able to find out that also. If you have any doubt in this problem, you can post the doubts in the comment section.